There are three tools you're probably already using to find information: Google, library databases, and possibly even AI tools. Here's the thing that is not obvious from just looking at three similar search bars. These three tools work completely differently from each other. They might look similar, but work fundamentally differently in how they find or generate the results they give you. That matters because the way you search needs to match how each tool actually works. Using the wrong strategy for a tool can waste your time or even mislead you completely. This module is about understanding what's actually happening inside each of these tools so you can choose the right one for what you want to accomplish. When you type something into Google, you're not searching the internet in real time. Google has already done that. It's been crawling and indexing web pages continuously, building a massive catalog of what's out there. When you search, you're searching that catalog. What determines what Google shows you first? Mostly two things: relevance and popularity. Google's algorithm looks at relevance as whether a page seems to match your search terms, and popularity as in how many other pages link to it and use it, which is a rough proxy for how trusted or authoritative it is. Pages that have been optimized to rank highly through something called SEO, search engine optimization, also tend to appear near the top, which means some results are there because someone worked to put them there, not because they're the best answer to your question. Google also personalizes results based on your location, your search history, and other signals. Two people searching the exact same thing can get very different results. Google is genuinely great for finding current news and events, locating a specific website you already know exists, getting a broad orientation on an unfamiliar topic, and quick factual lookups where accuracy is pretty easy to verify. But Google is built to give you the results that are targeted to you, not necessarily the most accurate ones. And it has no way to evaluate whether a source is credible, only whether it's popular or commonly used. Library databases are built on a different idea entirely. A database is a curated collection, which means someone or a team of people decided what goes in. What goes in? Usually academic journals, peer reviewed research, news archives, reference materials, and, in some cases, primary sources. Before an article gets published in an academic journal, other experts in that field have read it and evaluated whether the research is sound. That process isn't perfect, but items you find in a database have often been more carefully verified than what you can find in your average Google search. Because databases are structured and curated, they also let you search differently. You can filter by date, by source type, by whether the full text is available, by subject heading. Subject headings are standardized terms the database uses to categorize its content. Searching by subject heading rather than just keywords often gets you significantly better results. The trade off is that databases take more effort to use well. They reward knowing how to search, and sometimes searches feel a little more like a math problem than they do asking questions. But when you need credible sources for academic work, databases are usually the right tool to find results you can have confidence in. AI tools are genuinely useful, but the way they work is completely different from how most people assume. AI language models like ChatGPT, Claude, or Gemini don't search the internet when you just ask them something. They were trained on enormous amounts of text, and their answers are learned from books, articles, websites, code, and more. Through that training, they learned patterns. Which words and ideas tend to follow which other words and ideas? When you ask AI a question, its model generates a response by predicting what a good, relevant answer would look like based on those patterns. The AI generation process produces text that sounds confident and like it makes sense. It does not produce verified facts. The AI doesn't know whether what it's saying is true. It has no mechanism for checking. It can't look something up. It can't compare what it's saying to a source. And it can't tell you when it's uncertain, at least not reliably. It also has no true context. It's identifying patterns, but that doesn't mean it understands. This is where hallucinations come from. The model generates something that sounds plausible because it fits all the patterns, even if the underlying claim is false. And it can't check or even understand that it should. AI also has a knowledge cutoff, the point at which its training data ended. Anything that happened after that date, it simply doesn't have. And in most implementations, it can't access the most current information unless it's been specifically given that ability. None of this makes AI particularly useless. It makes it a specific kind of tool, one with strengths and real limits. We'll get into both of these in the next module. Let's take a real research question. What are the effects of sleep deprivation on academic performance in high school students? Here's what happens when you put that into each tool. In Google, you get a mix. Some news articles, some psychology websites, maybe a blog post, possibly an .edu page from a university health center. The results vary in credibility, and you need to evaluate each one carefully. Some will be excellent, some will be very basic, some might even be wrong. In a library database, you'll get news and magazines, but also get academic journal articles, studies that have been conducted on this exact question. They might be more complicated than the news articles, but they'll be substantive, using subject headings like sleep deprivation or academic achievement, and filters for peer-reviewed sources or recent publication dates will tighten this up significantly. In an AI tool, you'll get a coherent, well-organized summary of what research generally suggests about sleep and academic performance. It will sound correct and maybe even will make the most clear sense to you, but it won't give you a source that you can cite. And some of its claims may be generated, an output that the model thinks sounds as if it fits the pattern, but it is produced, not a fact. You need to verify these results independently with real sources before using them. Same question, three very different outcomes. How do we know when one is better than the other to use? Here is a short summary of what might be the best thinking for using all three of these tools for best results. Use Google when you need current news or events. You're trying to find a specific website. You want a quick fact check. Or you're getting oriented on an unfamiliar topic before diving deeper. Use your library databases when you need peer-reviewed or academic sources. Your assignment requires credible citations. You're researching a topic where you might need to find the data or methodology for results, or you want sources that have been evaluated before publication. Use AI when you're stuck on how to start and need to brainstorm how to proceed. You want help generating search terms for a topic you don't know well yet. You're trying to narrow or frame a broad question, or you want to think through the structure of your argument. AI is used best not as a source, but as a thinking partner. Each tool has a job. Matching the tool to the task is most of what search strategy actually is.